I am Nikita. Now I am telling about the X-ray powder diffraction. In that first we will discuss about contents, introduction to X-ray powder diffraction, fundamental principles, X-ray powder diffractometer, applications and lost limitations. First we will discuss about the X-ray powder diffractions. First, diffraction is defined as the bending of a light around or into the geometrical shadow of the obstacle. In powder X-ray diffraction, the diffraction pattern is obtained from a powder of the material rather than an individual crystal. Powder diffraction is often easier and more convenient than single crystal diffraction, as about 1 mg of material is sufficient for the study. Next, we will discuss about fundamental principles of XRD. X-ray diffraction is based on constructive interference of monochromatic of X-rays and a crystalline sample. For every set of crystalline planes in the fine powder, one or more crystals will be in the correct orientation to give the correct Bragg angle to satisfy Bragg's equation. Another fraction of the grains will have another set of planes in the correct position for the reflection to occur and so on. Also, reflections are possible in the different order for each set. The powder sample generates the concentric cones. It generates into a concentric cones of diffracted X-rays. Because of the random orientation of crystallines in the sample, we can see the powdered sample generates a concentric cones. If in this case we will see a concentric cones. Next we will see diffraction cones under Debye-Schicker geometry. In first picture we see that beam entry. In the second picture we see beam exit. In first we see a beam entry positions and the picture. In second one we see beam exit. Next for this I have explanation. All the like orientations what I shown in that like orientations of the grains due to reflection for each set of planes and for each order will constitute a diffraction cone whose interaction with the photographic plate gives rest to a trace. Instead of the sample generates only single diffraction spots, if generates cones of diffracted X-rays with the point of all the cones at the sample. The X-ray pattern of a pure crystalline substance can be considered as a fingerprint, with each crystalline material having within limits a unique diffraction pattern will be appeared and we see easily. Next, we discuss about the X-ray powder diffractometer, not diffraction. All of us will be confused with this word, but not at all it is. It is a diffractometer. A diffractometer is a measuring instrument for analyzing the structure of a material from the scattering pattern produced when a beam of radiation or particles interacts with it. We see the arrangements of line in a powder photograph in below. We see in the picture in the below we see arrangements of line in a powder photograph. This is the explanation and the definition about the X-ray powder diffractometer. Also we will show arrangement of line in a powder photograph. You can also see there is two pictures in that we can see clearly. Next, A is a source of a X-ray. In that picture is a source of a X-ray. These X-rays are generated by cathode ray tube. X-rays are filtered by monochromator to produce monochromatic radiation. It helps to choose the correct wavelength also. Not at all it filtered by monochromator to produce monochromatic radiation. It also helps to choose a wavelength. When we consider a slits like S1 and S2, then the slits S1 and S2 are used to adjust the shape of the beam, collimate to concentrate and direct the X-rays beam towards the sample, so that the powdered spaceman P, we consider like P as a powdered spaceman, get a narrow pencil of X-rays like a narrow pencil of x-ray. Means narrow means like the top is like a dot, it is called an narrow pencil of x-rays. Fine powdered is struck on a hair by means of gum. If the struck on a hair, it will appears like a gum. It is suspended vertically in the axis of a cylindrical camera. This enables sharp lines to be obtained on the photographic film, which is surrounded the powder crystal in the form of a circular arc. Okay. Next, the X-rays after falling on the powder passes out of the camera through a cut in the film so as to minimize the fogging produced by the scattering of the direct beam when the geometry of the incident X-ray impinging the sample satisfies the Bragg's equation. When it satisfies the Bragg equation means when the geometry of the incident X-rays impinging the sample, then it satisfies the Bragg's equation. Next, constructive interference also occurs and the intensity of the reflected X-rays is recorded by a detector, not it recorded as a symbol. The Bragg's equation on the constructive interference will be recorded, and the intensity of the reflected X-rays is recorded by a detector. Those three are recorded by a detector. It is a device, and the detector also processes this X-rays signal and convert it into a count rate, which is then output to a device such as a printer or computer monitor. What it means into a count rate, which is then output to a device such as a printer or computer monitor. In a more complicated apparatus, also a ganometer can be used for fine adjustment of the sample and the detector's positions. In more complicated apparatus also, this can be used for fine adjustment, like a little bit of adjustments of the sample and the detector's positions. Next, the unlost and other applications also is there for this. Next, powder diffraction is commonly used for chemical analysis, phase identifications. These X-rays powder diffractions is commonly used for chemical analysis and also phase identification of unknown crystalline materials, for examples minerals, inorganic components, like all these are the examples. These can be this is used for measure the unknown crystalline materials. Identification of fine grained minerals such as clays and mixed layers clays that are difficult to determine optically, but when we use the powdered X-rays diffraction, we can easily identify the fixed amount of layers. Determination of a unit cell dimensions also we can use. These are the applications. And last, this is also used for unknown quantities, and in all these we can use the X-rays powder diffraction. These are the uses, and these are also an important applications. And next, there are the limitations. The limitations of X-rays powder diffraction are the for mixed materials, the detection limit is 2% of sample. Peak overlay may occur and worsen for high angle reflections. When we see all these, we see a high angle reflections, a peak overlay will occur. These will get a disadvantage for this X-rays powder diffraction. So these are not benefit for us. For mixed materials, the detection limit is only 2% of sample, 2% of, and they will be occur peak overlay may occur, and high angle reflections. When we get high angle reflections, we can't able to see. So like these are the disadvantages for this X-rays diffractions. For unit cell determinations also, indexing of patterns for non isometric crystal system is complicated. These are very complicated also for the unit cell determinations, indexing of patterns for non-isometric crystal system. These are very complicated for us, and these three and so on. There are so many, but these are very fugue. Okay, for mixed materials detections limit is also a 2% of sample. Peak overlay will occur in this. So these are the limitations of X-rays powder diffractions. Okay, then thank you so much.